Let's discuss exercise 12K. Question number 1. This is very straightforward. Um, they will give the relationship. You don't need to find 3 and t square 3t. We don't know it is even, but maybe this is temperature and the time. So we want to find the theta over d, the rate of change of theta with respect to t. So d theta over dt, then 2t minus 3. That's all. 2. A equal to 5r. Area and we don't know. Simply we can find dA over dr. We don't know what is the relationship. So this is 2 pi. And question number 3. R equal 12t. So we want to find dr over dt. So r equal 12t minus 1. So dr over dt equal 12 minus t minus 1. So this is minus 12t minus 2. Minus 2. So dr over dt equal minus 12 over t square. Now in which point when t equal 3, dr over dt t equal 3. So this is minus 12 over t mean 3 square minus 12 over 9 minus 4 over 3. Question number 4. The surface area is square centimeter of an expanding sphere of radius r. So this is number 4. It is given a equal 4 pi r square. Then what we need to do is so we want to find the rate of change of area with respect to radius first. So dA over dr is 4 5 2 times r1. So this is 8 pi r. So this is any instance, any common instance this. But if you need a special instance, when r equals 6, we'll substitute and say d over d mean 8 times 5 times r is 6. That is 48 pi. What is this curve look like? If this is y, they all constants, right? Let's say 12, this is x square. So it kind of this kind of curve. So this is r and this is a. So this is the equation of the curve number 4, and this is d over dr. Then they need r equals 6. What is the meaning of that one? R equals 6. Let's say this is r equals 6. This is r and a. So what is this point? What is the gradient tangent line? So this tangent line value is d over dr 8 5 6 48 pi. So this 48 pi gradient is 48 pi at this point. Question number 5. Again, when you read, you can see that is displacement s and the time t square plus 8t. Now we want to find the rate of change of displacement with respect to t, which is ds over dt when t equal 5. So we'll find ds over dt first. That is, and you see this is a quadratic equation. Y equal x square plus 2 8x, like that. So it has a minimum value. So this is 2t plus 8. Then ds over dt when t equal 5, 2 times 5 plus 8. This is going to be 18. Question number 6. When you read the sum, after you get an idea, so you can see that we want to show that a equal y times 80 minus 2y. So this one we want to show. So we don't need to worry about these things. So first of all, we want to see what is going on. Okay, there is a house. This side is house, and they have a fence like this. This is house area, and so they have a fence. They explain this length is y and y, and total length is 80. Total length is 80 meter. Now you need a equation for a area. Now when I look at this one, okay, I have this one. To find area, I need this length. Then there's no length. So don't worry, take this length is x and we'll write. So what is the area now? Area of rectangular is yx or xy. Right? We done the for equation now. But we have a problem in this equation. Now I will take a equal xy. So that's how, when you multiply by xy, that's how we find the area of a rectangle. Now in this equation, a equal y 80 minus 2y, you can't find x, only y. Then you should have to develop another equation to substitute this x value. So we didn't use this data as well, 80 meter. Okay, what is this length? Y plus x plus y equal 80. X plus 2y is 80. So what is x mean? 80 minus 2y. We'll simply sub now. A equal 80 minus 2y times y. Yeah, we'll bring to y to this side, then we get the answer. We have the answer. Now, part B, given that the area is a maximum for this length of fence. Given that the area is a maximum for this length of fence. So it means rate of change of area with respect to this length is 0. So A equal 80y minus 2y square. To get the max, okay, we'll find dA over dy is 80 minus 4y. So they want the maximum area is maximum for this length. So area maximum when dA over dy equals 0, mean 80 minus 4y equals 0. 4y equal 80 when y equal 20. When y equal 20, the area is maximum. It means this is 20, this is 20, total area is 40, so this is going to be 40. So find the dimension of the enclosed garden area which is, and the area which is enclosed. So those are the length and the width, and the area is xy. What is xy? Area A is xy. X is 40, y is 20, 4 times 8, 0, 0 square. Only this part is differentiation part. Apart from that, the others are BCSE. Question number 7. This is about a cylinder, very simple. We want to show that volume and radius. And they are talking about surface area. Okay, first of all, we'll draw a simple cylinder. What is the surface area of this cylinder? So it has two circles. If you take, so this is R. So what is the area of a circle with R? Pi R square. So there are two sides. So 2 pi R. Now, if you if you cut this cylinder from here to here, and if you open, it's going to be a rectangular. Right? If I take this length h, so you can see this length is h. What is this length now? This length means this circumference. So this is 2 pi r. If you want, take a cylinder and cut and see. So this area is, now this is a rectangular, 2 pi r h. So I simply take this distance h length, because otherwise I can't write. We'll deal the this which later. First of all, get an idea. So now what is the total area? Total area is two sides, 5r square plus 5r square, 2 5r square, and uh, the curve area 2 5r times h. Now this value is equal to 600 pi. So I can see that this is pi is common. Then 2r square plus 2h equals 600. Actually, I can divide by 2. So r square plus h equals 300. I miss here r here, rh. Now, what we need to find? We need to find the volume. So simply we'll write volume equal. How do you find the volume of a cylinder? 5r square times height. Area times this area when you push h distance, right? If you push a dot, what will make a line? If you push a line, what it will make? It will make area. If you push a area, what will make? It will make a volume, right? If you push 1D, it will make 2D. If you push 2D, it will make 3D. If you make 3D, that will make 4D. If you push n d, it will make n plus 1. Those are abstracts. So I simply write the volume. So I write the equation, then I think what to do now. So basically now I can see in the equation, I can't see the given equation. H is not there. So I want to get rid of H. Actually now I find the equation for H. I have to simply substitute. RH equal 300 minus R square. Then H equal 300 minus R square over R. So I'll substitute here. V equal 5R square. 300 minus R square over R. This R to this one cancel out. So remain is 5R times 300 minus R square. Can you see a bracket on the answer? No. Then we'll take the bracket out. So 300 5R minus 5R cube. So we got the answer. The next part is find the maximum volume of such a cylinder. So how do you find the maximum volume of such cylinder? So this sum is about, so this is a curve, right? V and R. So it has, you can draw this curve. And if you select a different R's, you will not get the maximum volume out of, because you have 8, this is your area. If you take a, if you don't take the maximum R, and if you take a different R, and if you try to make this cylinder, what will happen? There are a lot of waste from this area, 805. So now we have to find what is the maximum area, d over d volume, d r equal 300 pi minus pi 3 r square, which is 300 pi minus 3 pi r square dv over dr. At stationary, dv over dr equals 0. So 300 pi minus 3 pi r square equals 0. 3 pi r square equals 300 pi. So this is cancel out, and 3 r square equal 100. R equal uh, square root 100 plus or minus 10. But radius can't be negative, because of that r equal 10. When you draw the curve, if you take r equal 10, so you will get the maximum value, so the maximum of this graph. And if you take any other r, you will waste this board. So we need to find the maximum volume. Now we found out r equal 10, then we equal 300 by 10 times pi times 10 cube. So when you solve, you will get 2005 cm cube. Yeah, 3000 minus 1000, 3005 minus 1000 by 2005 cm cube. Question number 8, question part A, show that the perimeter. So they have this one, this is R, this is OMN. So what is the perimeter of this one? So this is R, this is R. What is this length? If I take this length, you know that we can write this is R theta. Then what is the total perimeter? P is R plus R plus R theta. P equal 2r plus r theta. Now I wrote the equation 4, but when I look at in question number A, there is no theta, which I put by myself. Now I want to remove. So what is the area of this sector? Area is half a r square theta. This is the formula to find the area of a sector. This angle is theta. If it is 2 pi or 360, it is pi r square. So then it is 1 for one angle, 1 radian, pi r square divided by 2 pi. So this is cancel out. So r square 2. Then for theta size. So theta r square divided by 2. That is half r square theta. Very simple thing. Now area is given 100. So this is 100 equal half a r square theta. So theta equal 200 over r square. Multiply by 2 divided by r square. Now I can substitute here. P equal 2r plus r times 200 over r square. So P equal 2r plus r to r cancel out 200 over r. Is that the one? Yeah. Now there's an inequality also we won't look at. What is this inequality? R 100 over 5. It means if I square, will it change the side? Okay, R is positive. Everything is positive when I square. So I don't know what is I'm looking for. I'm searching. Okay, if I bring it here, pi r square great 100. Okay, what is pi r square? This is the area of a circle. Okay, actually area of a circle. This is the area of a sector. Area of a circle greater than area. Okay, now I the hypothesis area of a circle greater than area of sector. Greater than, no, greater than. Okay, then what is this? Is pi r square. This is 100. Now we work the other way around. R square equal 100 over 5. So r equal r greater than 100 over 5 square root. See, that's how my jotting. I just look at what is going on. Go backward and see. Then delete this one, erase this one, and work nicely. Now we want to find the minimum value of the perimeter. E equal to r plus 200 r minus 1. So dp over dr is 2 plus 200 minus 1 r minus 2. So dp over dr is 2 minus 200 over r square. dp over dr equals 0. 200 over r equal 2. So r equal 100. So r square equal 100. R equal square root plus or minus 10. So r equal 10. It can't be negative. Now we can find the perimeter. P equal this is going to be 2 times 10 plus 200 divided by 10, 20 plus 20, which is 40. Question number 9, when you're ready, after reading. And this length is R because this is R. And this is also R because this is a radius. So perimeter of the shape P is 40. Find the area. Okay, perimeter is 40. P is 40. Area. Um, area. How do you find area? Okay, this is a semicircle. So that is 5R square plus half. This is a R. This is 2R length because this is a diameter. Okay, now this area, rectangular area, length multiplied by width. There's no width. I'll take this is X. Now I can write 2RX. When I look at, there is no R in the given formula, so I have to remove X. Then it's fine. So how I'm going to remove X. So I need to use this one. P equal 40. Now we'll write P equal, this is 2R, this length, this is X, and this is 2 pi R divided by 2. Whole circle is 2 pi R circumference, half of it, which is 5R. And then this length X. So P equal 2R plus 2X plus 5R. So this value is equal to what? 40. Now this value. Now we'll make X as a subject and substitute here. 2X equal 40 minus 2R minus pi R. So X equal 40 minus 2R minus pi R divided by 2. Okay, I will divide R. 20 minus R minus 5 to R. X. We'll substitute here. So we need to write a proper writing. So I'm just basically this is equal 1 and this is equal to from 1 and 2. So A equal 5R square plus 2, 2R times what is X value? 20 minus R minus 5 by 2R. So is that the answer? I think I can see, but I have to simplify. 5R square plus this is 40R minus 2R square minus 5R square. 2 to 2 cancel out. So this is minus 5R square. This is 5R square half. This is also minus 5R square. So then 40R minus 2R square minus 5 over 2R square, because this is positive half, this is negative 1. So then minus. So yes, that's our answer is. That's fine. Hence find the maximum value of the area of the shape. Maximum. Now A equal 40R minus 2R minus pi over 2R R square. So dE over dr, rate of change of area with radius. 40 minus 4r minus 5 divided by 2 times 2r. So 2 to 2 cancel out. dE over dr equal 40 minus 4r minus 5r. Right. At stationary, dA over dr equal to 0. Then 40 minus 4r minus 5r equals 0. So then 40 equal 4r plus 5r. When I take r out, 4 plus 5. So r equal 40 minus 4 over 5. Need to find the maximum area. Then we have to substitute this one to here. So big calculation. A equal 40r minus 2r square minus 5 over 2r square. So A equal 40 times r equal 40 over 4 plus 5. Then 2 over 40 over 4 plus 5 square and minus 5 over 2. 40 minus 4 plus 5. So actually we can take r out and we can simply work out. Now we'll take 40 minus 4 plus 5 out. So this is 40, this is 2 times 40 over 4 plus 5. This is 5 over 2 times 40 over 4 plus 5. Now this value as for 4 plus 5, 4 plus 5, 4 plus 5 times 40. And yeah, this is going to be 20. So I'll made it, and then this is 80 over 4 plus 5, and this is 25 over 4 plus 5. Now I can take 40 over 4 plus 5 square. Then 4 plus 5, 40 minus 80 minus 25. So 40 minus 4 plus 5 square, this is going to be 4 times 40, 1600 plus 45 minus 80 minus 25. So this is 160. So 40 over 4 plus 5 square, this is 80, and plus 20. If I take 20 out, uh, 40, 40 times 20, this is 4 plus 5, and this is 4 plus 5 square. So basically this is cancel out, and this is 8800 over 4 plus 5. Question number 10, when you finish reading, you can see that this 1, 2, 3, 4, 5, 6, and this is x, and this is y. area of this grid. So one small box is xy. How many boxes? 1, 2, 3, 4, 5, 6, and 12. So 12xy is the area. So but they have a different area for A. So then I want to get rid of y because there is no y on that equation. A equal 1296 108 x square over 7. So there is no y. So I have to get rid of y. To get rid of y, they have given the length of the frame, the whole length of the frame. So how do you find the length? So this distance is 2y. How many 2y's? 1, 2, 3, 4, 5, 6, 7. 7 2y's plus how many x's? 1, 2, 3, and 3x 1 6. 6 times 3x equal 1 5 1 2. So 14y equal 1512 minus 18x, y equal 1512 minus 14x over 18x over 14. Now let's substitute here from 1 and 2. A equal 12x 1512 minus 18x over 14. 12 times 1512x over 14 and 12 times 18x over 14. So this is going to be 1296x minus 108 over 7 x square. Now we need to find the maximum area. So to find the maximum area, we want to find dy by dA over dx first. So dA over dx equal 1296 minus 1087 times 2x. Now dA over dx equals 0, then 1296 equal 2 times 108 over 7x. So x equals 7 times 1296 divided by 2 times 1 over 8. So this is 42. Now we can look at the second differentiation. Dx square equal minus 1087 times 2, and this is less than 0. So for the curve has a minimum. Sorry, maximum. If it is less than 0, maximum. So this is a maximum. Now we need to find the maximum value. So we have to substitute to the formula. So this is A over this one, and now we want to substitute when x equal 42. When x equal 42, A equal 1296 42 minus 1 over 87 times 42. So 6. So this is going to be 27,216 square millimeter. The model image is easy.